before the experiment is performed. Typical example is the experiments they are doing in the laboratory. Random experiment is one for which the outcomes are unknown before the experiment is performed. Unknown before the experiment is performed. So in the case of deterministic experiments, there is no ambiguity. They are all based on certain criteria, certain rules. Everything is known to us. Okay. Then when it comes to random experiment, there is uncertainty. Okay. This uncertainty is more. With this uncertainty, we need to know what would be the outcome of the experiment when we perform that experiment. We have seen several random experiments so far. One is tossing a coin, the other one is rolling a die. Just, yes, this is what we are referring to. Okay. Let me go back. So, tossing a coin, rolling a die. When we look into these experiments, we will notice that for some of these experiments, the outcomes are numerical in nature, while for some experiments, the outcomes are non-numerical in nature. Typical examples are, now you consider the case of say tossing a coin. When you toss a coin, the outcome is either head or tail. Okay. So what I have written is lost, right? Either head or tail. Okay. So there is an issue with this. So experiment we are dealing, let me repeat, deterministic and random. So in the case of random experiment, the outcome is unknown before the experiment is performed. Okay. In the case of deterministic experiment, outcome is known before the experiment is performed. Typical example is our laboratory experiments. When it comes to random experiments, we have seen a few examples: tossing a coin, then rolling a die. Any other example? Selecting a ball from selecting a ball. Like this, you can list out several random experiments. Okay. Say now, can you please give me one more example, please? Okay. Another example can be constituting a committee. This cannot be quoted under random experiment because whenever you form a committee, there will be definite rules. So I will include this. Okay. When it comes to the random experiments that are listed over here, okay,
Picking a card.
what are the picking a card? Okay, very good example. picking a card. Very good example. Normally, I don't consider, I will not explain this example. That's why I missed this. Okay. Thank you. What are the outcomes? Let us see the nature of the out. I don't say outcomes. I will say nature. Okay. Nature of outcomes. Okay. When you try to pick up a card from bunch, card is the outcome. Tossing a coin, what is the outcome? Head or tail? When you roll a die, what is the outcome? Any one of 6 digits. When you select a ball, what is the outcome? Ball is the outcome. Or color of the ball is the outcome. Okay. When you consider the nature of the outcome, okay, what is the nature of the outcome in the first column? The nature is non-numerical. In the second case, the nature of the outcome is still non-numerical. In the third case, the outcome is numerical. In the fourth case, the outcome is non-numerical. When I have a random experiment in the nature, when the outcome of certain experiments happen to be numerical in nature, while the outcome of certain experiments happen to be non-numerical, can I have a common platform where all the outcomes are represented by numerical, by set of numericals? Typically, you have 52 cards. Okay, let me have some numerical designation to all the cards. Say 1 to 52. So 52 cards. I have given numbers to each card. When I toss a coin, head or tail I can get. To each outcome, I assign a numerical value. Say head is 0, tail is 1. Tail is 1. When it comes to the third experiment, the third experiment outcomes include only numerical in nature, so I don't have to worry about that. The same numericals which come up when I toss roll a die can be taken. When I have the choice of selecting one ball out of number of balls, and I assume that all colored balls are available in that bag or box or urn, right? So for each possible color, I assume 7 colors are available. For each possible color, I assign a numerical value. Is it fine? Now, what is the essence of this discussion? Whenever a random experiment is performed, irrespective of the outcome of the experiment, whether the outcome of the experiment is numerical in nature or non-numerical in nature, I am assigning a numerical value to the outcomes of the base experiment. Once numericals are assigned, I always refer to the experiment outcomes through this set of numericals. In other words, I have sample space basically. I am representing this sample space by capital S. The outcomes of the experiments in this sample space are represented small. So in the textbook, you will see small s like this, lowercase s. Okay. Now, assigning numericals. These numericals are represented by small x, and numericals is represented by capital X. This capital is random. So what is random variable? And So how do I show it? Next, numerical. Is it okay? So each numerical value refers to a specific outcome of the experiment, and each outcome of the experiment is an element in sample space. Okay, is it clear? Okay, let me take a simple example of tossing a coin. In this, what I do, I have sample space S given by head tail. Okay, what are the elements of sample space? This is S1, this is S2. There are two elements. For each outcome of this experiment, because they are non-numerical in nature, I assign a numerical value, say 0, 1. This 0 and 1 together is represented by capital X. How do I represent the elements of this random variable? By lowercase letters x1, x2, and so on. Now, another experiment is rolling a die. Rolling a die is anyway. The outcomes are numerical in nature. Okay. Selecting a colored ball. Okay. Selecting a colored ball. All possible colors are there. What is the sample space? The sample space. What are the outcomes of the experiment? There can be violet color. There can be indigo. There can be blue, green colored ball, yellow colored ball, orange colored ball, red colored ball. Okay. Now, to each possible outcome, I assign a numerical value 1, 2, 4, 5, 6, 7. The set of these numerical values is represented by capital S. What are the elements in the sample space for this second experiment? Sample space elements are represented by S1, S2, S3, and so on, S7. Okay. To each outcome of the original experiment, I have assigned a numerical value x1, x2, and so on, x7. The collection of that set of numerical values is represented by capital X. Now the question arises is, what is the rule based on which the numericals are assigned? Okay. And once the numericals are assigned to the random variable, I can draw a real line where all numericals are placed. I can show on that line the values assigned to the outcomes of the experiment. In the second case, along the real line, I need to show. So 0 is not selected, no problem, right? 1, 2, 3, 4, 5, 6, 7. Okay. So when you see this figure, V is mapped to 1, I is mapped to 2, P is mapped to 3. Like this, there is a mapping of colors to the numerical value. You got it? In the case of tossing a coin, 0, H is mapped to 0, tail is mapped to 1. Now, what is the rule based on which we assign numerical values to the outcomes of the experiment? So, there is the mathematical rule can be decided by you. Okay. Instead of assigning H to 0, you can assign H to any value. Okay. If I have real axis like this, you can assign H to 1.5. It is left to you 3 point. The rule by which you assign numericals to the outcomes of the experiment is left to you. Only requirement is for each outcome of the experiment, we need to indicate a specific numerical value. We should never say h can be mapped to two different values or more different values. We should say h is assigned to only a specific numerical value. That is what the intention is. Is it clear? So normally we say x of zeta I, or simply don't complicate the things, x of s. So x of s is the rule by which a numerical value is assigned to the outcomes of the experiment. So the symbol x of s will indicate a number assigned to the specific outcome of the experiment s. Okay. So sometimes we can say let me see rolling a die, because here also we can employ this concept. The sample space contains elements. These are the elements of the sample space. Now, how do we represent the elements of the sample space S1, S2 and so on, S6? When I want to represent this set by a random variable x, I can have the same values, or I can have capital X as 10, 20, 30, 40, 50, 60. In first case, I have used the formula that S1 is mapped to X1. S2 is mapped to X2. So Xi equal to Si. In the second case, S1 is mapped to 10. What is S1? 10 times, sorry, X1 is 10 times S1. Is it okay? So Xi is 10 times Si. What is the difference between Xi and Si? X refers to random variable. S refers to sample space element. Element in sample space. Is it fine? Any questions till now, please? So Si refers to element in sample space. Xi refers to random variable. Any questions, please? Okay. So Akshit is online, please. Akshit is there online. Okay. Who is there online? You can unmute and speak, please. Okay. Madhu, then Amrita is there online?
Sir.
Any questions till now, Amrita?
No, sir.
Okay. Advaita is online, please.
Yes, sir.
Any questions, please?
Sir. Yes.
Yes. Meet is there online?
Yes, sir.
Any questions?
No, sir. Clear.
What is your name, please?
Meet.
Okay.
Sir.
Okay. If there are no questions, let me go back to the concept. Okay. Just now, I have been calling you by names. Okay. Here, what is the rule involved? Rule involved is I have referred to the participant list. I have referred to the participant list. I have called the names in exactly the same sequence as listed. Sequence is same as reported in the list. Okay. So suppose you do not know from where I am calling the names, then probably you might think that I am calling the names randomly, isn't it? Because you are seeing the screen. Whenever I refer to the participant list and I call some of the names, then you will understand that I am following the sequence that is displayed on the screen. Okay. Suppose you don't have the opportunity to see the screen which I am using, then you probably think that I am calling your names randomly. Assuming that I am calling the names randomly, what is the experiment here? Experiment is calling the names of the students. Okay. Then what is the outcome? Name. So each name is distinct. Now I want to assign a numerical value to all the names assigned. The name which is called first is given value 1. The name which is called next is given the value 2. Like that, I will give different numericals to different students. Okay. This set of values is represented by random variable x. Random variable is represented by capital letter. It can be W, X, Y, Z, or A, B, okay, whatever it is. Corresponding lowercase letters are used to represent the numerical values associated with the random variable. Now let us see another set of examples. The random experiment we are considering. Suppose I have purchased a 1 meter cloth. Okay. So they have in the shop 1 meter length is measured and that was cut and it was handed over to me. With a precision instrument, okay, if I see the length of that cloth, suppose it may be 1 meter plus a few millimeters. Is it okay? This is one example. But how much of this may vary from shop to shop, or it may vary even if the same person attends to this work. Okay, that is one example. Another example is in your timetable, you have allocated 1 hour of time for general reading, a reading that is not related to your academics. Suppose you are interested in some literature, you start reading literature books. You are interested in arts form, you start learning that or reading corresponding knowledge textbooks. Okay. In 1 hour, how many words can you read? In 1 hour, how many words can you read? How many words can be read? How many words? N number of words. N can be 100, 1000, 2000, so on, right? But that is definite numerical value. In the previous example, this variation can take any value, right? So in the first example, actually 1 meter length is expected. It can be Slightly above that most of the time, rarely it will go down, right? Suppose it is 1 meter, this deviation is say 1 millimeter, say 10 millimeters, okay? 1 centimeter, right? So when we have this much deviation, what we say, the values associated with experiment 1 can be represented by set of values which are continuous in nature. Another example could be the voltage waveform which has swing from 0 to 1 volt. How many possible values the signal can take? An infinite number of values. Whatever value you mention between 0 to 1 volt, you will find that value being taken by the signal voltage. Okay, so that is referred to as continuous sequence of values. In the second example, the number of words that you can read or number of words only, right? That is always a finite discrete value. That is referred to as discrete random variable. If the random variable takes discrete values, that is referred to as discrete random variable. If the random variable takes a set of continuous values, that is referred to as continuous random variable. Is it fine? Discrete, okay. There is another nature of random variable where the random variable takes sometimes continuous values, sometimes discrete values. That is referred to as mixed random variable. Okay. If we discuss in detail continuous random variable and discrete random variable, the combination of these two is our mixed random variable. So our concentration will be with on continuous random variables and discrete random variables. Okay. Okay. Now, till now, let me summarize. I have considered a random experiment. Okay. So always please appreciate this type of thinking. Deterministic experiment can be deterministic, experiment can be random. Okay. Okay. Let me deviate from here a little bit. How do you view life? Is life can be continuous deterministic experiment or random experiment?
Random.
Deterministic, random. Okay. How many of you agree?
Deterministic. Deterministic.
Okay. Any other opinion, please? Can anyone say it is neither deterministic nor random?
So, it's mixed, I guess. Like some situations are deterministic and whereas some are random.
So, okay. Some are deterministic, some random. Any other response, please? How can you say that life is deterministic? The person who said life is deterministic, can you please tell me the reason why do you conclude that?
Sir, I thought it will not be always a random thing, no, sir.
Correct.
So I thought in that way, maybe deterministic.
Okay.
But when
Any other
option
thing?
3 is introduced, I thought option 3 would be right. Neither
Okay. Okay.
mixed
I agree.
version.
Okay. Can you please tell me a few things that come under mixed version? What things you think as deterministic? What things you think as random? So please, you are now in the middle column, okay? Or second column, fine. Deterministic is first column,
Age of a person is deterministic.
Age, right? Is it clear? Age is deterministic. Is it correct? Okay, any other thing? See, at the age of 60 also, there are persons, very few, who are more active than those who are at the age of 20, right? Sometimes in newspapers we notice, right? Any other? See, if you say life is deterministic, I will argue in favor of random feature. If you say life is random, I will argue in favor of deterministic. So I have the choice. The way you perceive is the way you understand. Okay. If I say life is deterministic, yes, it is something like this. I have my own timetable. See, so for every hour I have activity. Okay. Then I have health checkups. Then I will have other related things to be taken care. All the possible things. Then I can say life is deterministic because everything is planned. How did you get admission into NIT Warangal? Because your parents planned that you should be in engineering stream. Yes or no? So they have made a deterministic plan that you should be in engineering. You also made a deterministic attempt so that you can get into engineering stream. And you got a good rank and you have been in NIT Warangal. That is how deterministic is. When it comes to random, your parents expected you to be in IIT. You also expected to be in IIT. It so happened that you could not do well, so you got little less grade or rank. So that is how you are in NIT Warangal. You never thought that you would be in NIT Warangal. That is how I consider life as random. Is it clear? For those who did not have choice, who did not have preference, right? They want to get into engineering stream. Either NIT or IIT doesn't make any difference, but IIT is better, NIT is also good. Effort was placed, concentration was there. So people have come into NIT Warangal. That is how life becomes sometimes deterministic, sometimes random. So comes under second column. Any further explanation from your side, please? This is how I used to explain the concept of random experiment. Okay. Anyone would like to add further? Experiment can be deterministic experiment and experiment. Interested in experiments. Output to be predicted. There should be some mathematical way of doing possible. Under what is that random? Then considered outcome. We have defined points that the nature are numerical process is non-numerical. The non-numerical is numerical. The set of will value by a random variable x. Still now values assigned to random can be considered. The values can be sometimes values are present, some values are present. So based on this, in the case of variable, values are in here, the corresponding variable continuous random variable takes values discrete as well as continuous. We refer to that mixed
Your
random
voice
variable.
breaking.
So for yes, what is what point would you hear? Let me check this. What point could you hear properly? So based on the nature of a random variable, we can classify a random variable as discrete random variable, continuous random variable, and mixed random variable. In the case of discrete random variable, only discrete values are assigned. In the case of continuous random variable, a set of continuous values are assigned. In the case of mixed random variable, the discrete values as well as continuous values be present. So for each outcome, specific numeric value is it a specific numeric outcome is probably associated with that. Hence, each specific numerical outcome there is probability associated with that. When I plot probability on y-axis and on x-axis, I will plot value of the random variable. Is it okay? I use the random variable. Now I can consider the experimental head tail. Values assigned to that are say 0. So all events are equally likely. So the probability of head is the probability of getting tail to this of that case. How do I represent the probabilities as a function of value variable is of here and it is this one. Is or
Sir, your
assign
sir, your
different
voice
set
is
of
still breaking.
is
Sir, your voice is still breaking.
is
Yes, sir, it's not clear.
what point here?
Uh,
Your voice is also great.
yeah.
I will okay.
It,
Let me consider an example where rolling of a coin is being considered. Tossing of a coin, the possible outcome head tail. So the scientist got two outcomes, head comma tail. The concept of random variable can represent head tail by specific numerical value. The collection of numericals is indicated by random variable x. Okay. So x is 0, comma 1. When I want to the value of the random variable along with its probability in a t like that by line segments correspond to 0 corresponding to 1 tail. Okay? So the probabilities are given by y-axis represents the probability of a possible outcome. Is it clear, please? Please respond. Still, if my voice has lost the continuity, then I need to explain again. Please let me know. Kirti Kiran, voice is continuous or Amrita Kiran? Akshit,
Sir, your voice is kind of
my
breaking.
voice is continuous or
Still breaking, sir. It's not clear.
please. Um, Could you get the example, please, or no? Do you
Sir,
understand the example which I am trying to
No, sir.
explain?
Not
no,
clear
sir.
yet.
Oh. Is it clear that each possible outcome has got a specific probability? Since each outcome is represented by a specific numerical value, associated with each specific numerical value, there is corresponding probability. That part is clear? Let me see the charts, okay? Okay. Now is my voice clear or still red? See, you responded that not listen clearly. Close and
Sir, your voice is still breaking.
okay. I could hear your voice clearly. Now, are you able to hear my voice? Still breaking, right?
Yes, sir. It's still breaking.
Sir, it's breaking, please.
What I can do now? If you have questions, probably it is the network. Now, what is the quality of voice being presented to you? Please? Now, is it what is the quality of voice right now? Now you can type the chat box. What is quality of
Now it's better, sir.
voice?
Yes, sir.
Still breaking.
Now it's fine, sir.
So how do we usually stop? Okay. Okay. I will do one more time. I will disconnect and okay. Okay. Now you please let me know the quality of voice through the chat box. Just type in whether the quality of voice is fine or not. Amrita has responded, but it is 1 minute back. The voice is still breaking. Amrita is responding. Okay. Then, okay. Now the voice is still breaking, please.
Yeah, now it's clear,
Someone
sir.
else can respond. Now it is fine.
Yeah, now it's fine.
Little distant. Now it is fine, right?
Yes, sir. Now fine.
Let us continue. Is the experiment is clear, please? Okay, I will repeat the explanation example. I am considering the example of tossing a coin. Whenever I toss a coin, the sample space has got two possible outcomes, head or tail. From the concept of random variables, I have represented head by 0, tail by 1. Okay. Since each outcome has got a specific probability, I am considering that all events are equally likely. P of H, P of T are considered from sample space. From the concept of random variable, what I write is P of 0 as half, P of 1 as half. Now, I want to represent probabilities with corresponding numericals on a plane. Along x-axis of that plane, I will show values of random variable. Is it okay? Along y-axis, I will show the values of probability. Is it fine? Now, when the random variable takes a value of 0, what is the probability associated with that numerical value? Half. Okay. When the random variable takes a value of 1, what is the probability of that event? It is still half. Okay. So that is how I will show the probabilities. I hope this is clear now. Okay. I am looking at the chat box. If there is a problem, please type in that chat. Okay. The concept is normally what we do. I have a signal as a function of time. See voltage along amplitude of the voltage along y-axis, time along x-axis. What is the thing of interest to us? I want to know as a function of time. Okay. So dotted lines are the actual signal. So for value of time less than or equal to 0, is the sum of the values. Time less than or equal to t1. What is the sum of all the possible values? This is what I want. Why I want to know? By the time the signal becomes 0, say at t equal to x, by the time the signal becomes 0, I want to know what are all the possible, sum of possible values the signal took. Okay, this concept is very much relevant to the probability. The reason being, when the experiment has got, say, n number of possible outcomes, the possible outcomes are 1, 2, 3, 4, 5, 6. Say the example could be rolling a die. Whenever I roll a die, when I assume all events are equally likely, what is the probability of getting 1? 1 by 6. Probability of getting 2? 1 by 6. 3, 1 by 6. 4, 1 by 6. Probability of getting 3 is also 1 by 6. Probability of getting 6 is also 1 by 6. Now I want to know what is the probability of getting values less than or equal to 1. It is half only, because there is only one event that is possible with x taking a, sorry, here I write random variable x. Okay, and it is x. Please see the difference. Whenever the random variable capital X takes a value less than or equal to 1, at 1 I have probability of half. So the same value continues till that value X. Next thing is, what is the sum of the probabilities when the random variable X takes a value less than or equal to 2? X equal to 2, there is a probability of half whenever the random variable takes a value less than or equal to 2. I should sum up all the probabilities. What is the mistake in this example, please? I should take 1 by 6, not 2. I hope you can appreciate. Okay, this is 1 by 6. Add 1 by 6 at this point, it becomes 2 by 6. Is it like that? At X equal to 3, I will get 3 by 6. Like that, 4 by 6, 5 by 6, 6 by 6. Okay, let me draw that figure here. See, probability along, I will not label the y-axis right now. I will label only the x-axis, values of random variable x. Okay, random variable x takes a value of 1. I have got probability of 1 by 6. When random variable takes a value of 2, I will show half a continuous. Then here it goes up. This is 2 by 6, 3 by 6, 4 by 6, 5, 6 by 6. At t equal to 2, 1 by 6 is added, 3, 3 by 6, 4, 4 by 6, 4. What is this graph? Whenever the 3, 4, 5, then here 6. Whenever variable x takes a value exactly equal to 1, there is an event happening. Whenever random variable takes a value less than or equal to 1, that is indicated by 1 by 6. This 2 by 6 is nothing but this random variable taking a value less than or equal to 3 by 6 is random variable taking a value less than or equal to 3. Like this, what is this final value? Random variable taking a value less than or equal to 6. When you see, I have been adding up the probabilities of events before x taking a specific. So what I show it is basically y-axis I have plotted probability 1. Along y-axis I have plotted probabilities. Now in this figure along y-axis I have shown probability of x taking a value less than or equal to specific value of x. Okay. So the quantity that is being plotted along the axis is referred to as cumulative quantity, right? That is referred to as probability distribution function. Probability distribution. Is it fine? We define that probability distribution. We represent that by fx of x. And we define it as probability that random variable takes a value less than or equal to small x. Small x can be less than or equal to 1. Small x can be less than or equal to 2. In our present case, can be less than or equal to 6. Okay. What is x taking a less than or equal to probability? Because x equal to 1, sorry, x equal to 1 is included, is 1 by 6. What is the reason? There are 6 possible outcomes. When I consider probability of x taking the value less than or equal to 2, it includes actually 2 events, probability of x equal to and probability of x equal to. These are independent. So 1 by 6 plus 1 by 6. That is how 2 by 6 has come. When I consider probability of x taking a value less than or equal to 1, it includes 6 events. One is probability of x equal to 1, probability of x equal to 2, and so on. Right? X equal to 2 and so on. Probability of x equal to 6. How many such probabilities need to consider? 6. It is 1. So once a sample space is defined, once numerical values are assigned to this limits of sample space, once random variable is defined, I can always plot a function referred to as probability distribution function, which is defined as probability of x, random variable x taking a value less than or equal to small x. Is it okay? Any questions on this, please? So we show like x is x values along this. Okay. In this case, this is a staircase waveform. This is 1, this is 2, 3, 4, 5, 6. Any questions still now, please? Are you with me? Any questions from your side? No. Meet can respond.
No doubt.
Okay, great. Now voice is clear. Right?
Yes, sir.
Once the distribution function is defined, please. Any questions? Okay, if there are no questions, once the distribution function is defined like this, I want to know what is the slope of that distribution function. It is normal technical interest, right? That slope is defined as probability density function of x. So a new function has come, probability density function. It is denoted by fx of x. It is defined as derivative of distribution function. See, in mathematics also, suppose the you have seen Fourier transform, right? Suppose I have a time domain signal like this. A what is this pulse? A rectangular pulse. When you take the derivative of this time axis amplitude, okay, dv by dt. So you will expect one impulse at this point. You expect another impulse at this point. What is the importance of this figure? In this interval between two successive impulses, there is no change in signal amplitude. Some inferences you can draw by looking at derivative of a given function. Or you take the derivative of a given signal. You can always find out the points where the is maximum. So the slope becomes 0 here. The slope becomes 0 here. The slope also becomes 0 here. So once you have probability distribution function, the immediate follow-up is the density function. So let me start. Any questions from your side, please? Please place some questions so that it's helpful, right? Advaita online, please.
Yes, sir.
Akshit.
No doubts.
You are able to follow. Is there any new thing did you come across or concept or old? Did you get new concepts? Concepts are already known to you. Hemant is online. Vishal Reddy, Yajna, Shwini. Venkat, Varun,
No, sir, no doubts.
Right. See, whatever you have heard today, are they new concepts or concepts which are already known to you? The concepts are new or already known to you? Vishal responded yes, no? The concepts are new or already known?
Some are of new concepts, sir. Some we don't know.
Which are new concepts, please?
Probability
Which are
density
new
part,
concepts?
you have shown that the derivative part, this part is new.
Probability things are known to you, right? Random
Yes, sir.
variable is also known to you.
Yes, sir. Yes, sir.
Random variable. Random variable things are known. Distribution function also known to you, right? So, okay. I will close this session for today. Thanks for staying with me, and I hope the discussion was nice, right?
Thank you, sir.
Thank you, one and all.
Thank you, sir.
Thank you, sir.